This is the examples video for the lesson on analyzing graphs of quadratic functions. To start off with, we have to find the axis of symmetry of this function. Well, as we learned some time ago, the axis of symmetry is just when x is negative b over 2a, which in this case is negative a negative 3 over twice 1, which is just 3 over 2. But that's a little lame. Right now, let's try this by completing the square. Well, if I wanted to complete the square for this part, I need to take half of this term and square it. So here, I'm going to have x squared minus 3x. Now half of that is minus 3 halves. Minus 3 halves squared is, well, we can just leave it as that. But if I still want to have this plus 2 here and have it be the same thing as it was before, I'm going to have to go ahead and subtract a 3 halves squared over here. That way I really just have the same thing. It's like adding 1 and subtracting 1. So now I can group what I have in blue together. It's really just x minus 3 halves squared. And this is just minus 1/4. And that's because here, this is really 8/4 minus 9/4. So I'm going to stop right now and notice this is the equation in that form we learned in the lesson. And here, a is equal to 1, b is equal to 3 halves, and c is equal to minus 1/4. And b is just our axis of symmetry, so we know that this is our answer. But it really should be, if they ask for the axis of symmetry, they want something that looks like x equals b. So really you should say x equals 3 halves. And there you go. For number 2, it's asked which of these has the widest graph. Notice that not all of these are in the form we learned in the lesson video, where it's just a times the quantity x minus b squared plus c. This means that we're going to have to kind of explore what this means. If I wanted to try using the completing the square method like I did in the previous problem to figure this out in the form that I would like, well, I really know that there's nothing I can do about this minus 7. I can't do anything to get that out of the way, because it has to be minus 7x squared. So in fact, whatever the coefficient of x squared is what our a is. So in the first case, a is 7. In the second case, a is 4. In the third case, a is minus a half. In the last case, a is 3/16. Now, whether the a is positive or negative, we know, just tells us if we open up or down. When we want to ask if it's wide or narrow, we look at the absolute value. So in this case, only one of these isn't positive already, so I'll just take the absolute value of this minus 1/2, and it's 1/2. So now we ask which of these is the smallest. Whichever is the smallest is the widest graph. So 7 and 4 are obviously bigger than 1/2 or 3/16, so we know it's not that and it's not that. Because 1/2 is equal to 8/16, we know that 3/16 is smaller, so this is not the correct answer, but this is. For example 3, we have to find the vertex of this quadratic. Well, we could use the formula x is negative b over 2a to find the x value, and then plug that in to find the y value of the vertex. Let's try doing it by completing the square and getting this function into that form we used in the lesson video. So if this is our function, we want to complete this. So if that were a perfect square, what's underlined in blue, then that extra c term would be half of negative 4 squared, which is half, well, it's negative 2 squared, which is just 4. So that means we end up with x squared minus 4x plus 4 plus 5. But if I added 4, then I'll have to subtract 4 as well. So here, I'll subtract that 4. So now I can factor what's in blue here as x minus 2 squared. And 5 minus 4 is just 1. So it's of this form. This means my vertex is going to be the b value, which is 2, for the x component, and for the y component, it's the c value, which is 1. So the solution for the vertex is 2, 1.